Welcome back, biologists. It's Mr. Forberg here, and today we're taking a look at a short free response question coming from the 2016 exam. In this question, it's going to start off right with a diagram, and right away I can tell that this is a eukaryotic cell. I see that I have a cell membrane, inside is a nucleus, and that nucleus is filled with some DNA. Now, what's going on inside the cell? Well, I see that DNA is being processed, we're getting RNA, and finally we're getting a protein, so I'm looking at protein synthesis and a few steps that are going to be required to get to that final protein product. So I have a pretty good handle about what this question is asking me about. Let's dig into the text itself. Now, it says that the figure represents the process of expression of gene X in a eukaryotic cell. Part A says the primary transcript in the figure is 15 kilobases long, but the mature mRNA is only 7 kilobases in length. Describe the modification that most likely resulted in the 8 kilobase difference in the length of the mature RNA molecule. We'll then identify in your response the location in the cell where this change occurs. So the first thing that we're going to look at is what are those action task verbs. All right, the first one is describe a modification. It gives us this 8 kilobase difference. All right, so if I want to go back to my model here, I can see that this is the transcript that we're referring to. This is actually 15 kilobases in length, yet we get this mature transcript that is only 7 kilobases. So the question is really what happened to those other 8 kilobases? And we know that what's happening between this step and this step is RNA processing. And in this process, we're actually removing all the introns from the immature transcript, and we're going to splice those exons together. And in doing so, by removing that DNA, we're going to get a shorter transcript. So that gives us the first piece. Taking a look at the second part, we now have to identify the location in the cell where this is occurring. And this one's pretty straightforward as well. We know this is a eukaryotic cell, and this process of processing is all taking place in the nucleus. So now that we've got part A taken care of, let's take a look at part B. In part B, we're going to predict the length of the mature gene X mRNA in a full-length gene, or I should say if the full-length gene is introduced and expressed in a prokaryotic cell. We then have to justify our prediction. So the first thing that we're going to do is we're going to identify that task verb. We're going to predict the length of this particular gene X mRNA, right, under the conditions of being in a prokaryotic cell. So really what it's asking for us is to examine how do eukaryotic cells express their genome differently from prokaryotic cells. And what we know is a eukaryotic cell is going to go ahead and separate that between the nucleus here and the cytoplasm out here. However, a prokaryote doesn't have that nucleus to segregate those two particular processes. So a prokaryotic cell is actually going to translate the entire genome, or I should say any mRNA expressed. They don't process that or remove any introns. Because they don't do any of the mRNA processing, I'm going to predict that that length is going to be 15 kilobases long because there is no editing going on. In the second part, I now need to justify that prediction. So simply put, we're just going to elaborate on the fact that we said it's 15 kilobases long. All right, prokaryotes do not carry out mRNA processing. Do not. This question was as simple as that. Hope you did well. Thanks for tuning in. We'll see you next time.